Hi, in this video, I'm going to talk about the relative sizes of atoms. So remember previously I said that sizes of atoms is very, very small. What was the sizes? I mentioned that atom sizes range from about 1 angstrom to about 5 angstrom. Angstrom is 10 to the minus 10 meter, right? So it's 10 to the minus 10 meter to 5 times 10 to the 5 times 10 to the minus 10 meter. At the same time, I mentioned that there are about 118 atoms are known up to this date. So 118 atoms, but the sizes ranges from 1 to 5 times 10 to the minus 10 meter. So it doesn't seem like the atom sizes, as you would imagine hydrogen being atomic number 1 is the smallest and lightest. But let's say the heavy one, like for example, radon, having an atomic number 86, it doesn't mean that atomic number 86 is 86 times larger than hydrogen, because the sizes just varies from 1 to 5. So let's see. What is making atomic, what kind of a force is binding the atomic structure? There, in a nucleus, there are neutrons and protons. And protons' electric charge is positive. How about the electrons? Where is the electrons locate? Electrons locate outside the nucleus, right? And what kind of a electron is electrically charged negatively charged, and the proton is positively charged. And if you have an oppositely electrically charged, then they have an attractive force. So what kind of a force is binding the making atomic shape? It's the electric force that's binding electrons that don't fly away out from the nucleus. If imagine as you have an increase in atomic number, then you have more protons, and so as the electrons. If you have a proton, 3 protons, that means you have 3 electrons typically, right? So you have more and more numbers of electrons and protons. That means that the force between them becomes stronger. So, for example, if you have a hydrogen to helium, helium is atomic number 2, and then hydrogen is atomic number 1. Now I'm going to show you the screen. Let me just share the screen. It's easier. Here. So this is the periodic table, and we have a hydrogen all the way up on the top left corner, and then a helium is the atomic number 2. That's in the most right top corner. So hydrogen to helium, you have atomic number that changes from 1 to 2. That means the number of proton increases 1 to 2, and so as electrons increase to 1 to 2. So all those, it moves from hydrogen to helium. So what do you think is that sizes, what happened to the size from moving from hydrogen to helium? Do you think the size would increase? Can the size be decreased though? The size actually decreases as you move from hydrogen to helium, because you have an increased number of a proton and electrons. That means that those electric force becomes stronger, and then it attracts electrons even more, so that the hydrogen, let's say, is this size, then the helium becomes this size. It attracts more, so actually it becomes smaller. But then what happened if you move on to lithium, which is in the second row on most left column, right? Lithium has atomic number 3. And therefore, how many number of electrons does the lithium have? 3 electrons. So lithium has 3 protons and 3 electrons. But what happens to the electrons is you have a first 2 electrons sit on the first shell. So the third electrons cannot fit anymore in the first shell. So they have to be sitting on the second shell. So actually the size of atom, although you have a more number of protons and electrons in a lithium, so you have a stronger electric force. However, because the the third electron cannot be in first shell, it has to move on to the second shell. So the size actually increases when you move from hydrogen to lithium. Then what happens when you move from lithium to beryllium, boron, carbon, nitrogen, oxygen, and fluorine, and neon, right? As you move from left to right on the second row, you have more atomic number increases from 3, 4, 5, 6, 7, 8, 9, 10, right? So what's the number of protons and numbers of electrons? So as you move from lithium to neon, from left to right on the second column, again, the sizes increases from helium to lithium, but then moving from 3 to 10, the lithium to neon, the sizes, because as the increasing number of protons and electrons, sizes decreases. So you move from lithium to neon, the size of the atom decreases. Then after neon, moving into sodium, the sodium jumps up to the third shell, the 11th electron is going to be sitting, it can't fit no longer in a second shell, so it has to move up to a third shell. So again, when you move to the sodium, which is again the most left column, the size is, boom, jumps up again, because now it's in the third shell. The electron is in the third shell, so it just the size of the atom becomes larger. And as you move from sodium to argon, from the atomic number 11 to 18, from left to right, the sizes decreases. So that's the reason why the size of the atom does not increase linearly as the atomic number. So it depends on the electron shells. If you move from left to right, because you have more in the same electron shells, if you have the same amount of same electron shells. So if you're in a third shell, then if you move from left to right, the size of an atom decreases. Okay, so this is going to be the relative sizes of an atom. So move from hydrogen to helium on the top row, you see the sizes actually shrinks from left to right. But then if you go down to the second shell, lithium to neon, helium to lithium, sizes, boom, increases, because now you move from first shell to the second shell, first shell to the second shell. So from helium to lithium increases. However, from lithium to neon on the second row, moving from left to right, it decreases again. And then from neon to sodium, the size again increases. And then decreases as you go from left to right. And then when you go down, it increases. So that's the reason why that atom sizes ranges from 1 angstrom to 5 angstrom. It doesn't really go to 1 to 180. All right, so let's see again. What is the force that's responsible for binding the atom? And does the atom sizes, does it change linearly as the atomic number? Okay, those are 2 questions that I have for this lecture, and then you answer. And I'll see you in the next video.